Around 9,000 years ago, massive radioactive solar tsunami struck Earth. An international research team has studied ice cores from Greenland and Antarctica, and found traces of a powerful solar storm that hit Earth about 9,200 years ago, during a period when our Sun was experiencing a peak minimum of activity. Under certain conditions, bursts of energetic particles can reach the Earth and even paralyze communications and power systems. They also have a detrimental effect on satellites and air transport operations. For these reasons, it is important to understand the mechanisms and contexts that facilitate their development. These events are currently thought to be most likely to occur during solar maximum, when our star's geomagnetic activity is at its peak. However, recent work challenges this paradigm, especially with regard to the most intense and, unfortunately, the most threatening solar storms. A powerful solar storm occurred 9,200 years ago during a deep minimum of activity. Measurements taken by researchers on ice cores from Greenland and Antarctica showed that an extremely powerful, and previously unknown solar storm occurred about 9,200 years ago. This storm occurred at a time when our star was experiencing a deep minimum of activity. Therefore, the authors argue that if such an event were to occur today, in addition to taking us by surprise at an unexpected time, it would have serious consequences. Such a powerful geomagnetic impact would be able to turn off power systems, disrupt the operation of various communication systems. To come to these conclusions, the scientists analyzed the content of beryllium-10 and chlorine-36 in the nuclei. It is known that these isotopes are produced by high-energy cosmic particles that reach the Earth during solar storms. They are able to remain in ice for thousands of years. This is a time-consuming and expensive analytical work, said geologist Raymond Muschler. Therefore, we were pleasantly surprised when we found such a peak, indicating a hitherto unknown giant solar storm that occurred during a period of low solar activity. Of course, the results obtained by the researchers will require further work to understand the mechanisms involved in these storms occurring in conditions of stellar calm, and ways to protect against them. Concentration of beryllium-10, 10B, chlorine-36, 36Cl, or carbon-14, 14C, in ice cores from Greenland, NGRIP, GRIP and EGRIP, or Antarctica, EDML, about 9,000 years ago. The 25th cycle of solar activity, counted from the end of the 18th century, began in the middle of 2020. Since that moment, spots appear more often on the Sun, and flares and coronal mass ejections occur, which, having reached our planet, cause perturbations of the magnetosphere. In some cases, storms can provoke coronal holes, areas on the Sun from which a stream of high-speed solar wind emanates. Observations of flares and coronal holes make it possible to predict magnetic storms on Earth several days in advance. But if such powerful solar storms were possible thousands of years ago, when the Sun was at its period of minimum activity, then they should be possible today as well. And this type of activity is not as easily traceable, and we might not know that it is coming our way. And besides shaking operation of systems on Earth, such unexpected disturbances might have a much more destructive effect. Let me mention a case from the Cold War when Americans almost started a new war due to an unannounced solar flare. Nuclear war because of an unannounced solar flare? At the height of the Cold War, on May 23, 1967, the Americans began to prepare their air force for war, thinking that the national surveillance radars in the polar regions had been disabled by the Soviet Union. They were saved from an irreparable mistake by military space weather forecasters, who reported that a powerful flare was seen on the Sun, which could affect the operation of radars and radio communications. Preparations for hostilities were suspended, and a potential nuclear exchange did not take place.